Hello everyone, I hope you are doing very well. So welcome to this class. So today we are going to start chemical reaction and equation NCERT exercise. Okay, so this is the first chapter in our book, NCERT book. So as you know very well, in chemical reaction and equation, in lower grades you understood what is chemical reaction, right? So again, I want to recall the points, and in theory classes you have understood what is a chemical reaction and how can we balance this any chemical equation, right? Because you know very well chemical equations must be balanced. Okay, why? We will discuss that definitely. So in chemical reaction and equation chapter, first of all I want to recall the important points of this chapter. In chemical reaction and equation chapter, first of all we had discussed what is a chemical reaction. Suppose iron piece is here, right? And due to the presence of moisture and oxygen, after some time you will get a reddish brown layer on the surface of this iron object or iron piece. So what is this reddish brown color layer? This is a reddish powder. What is that? That is named as rust. And this process is named as rusting. It means something is happening here, that is because chemical changes occurring here, right? Because chemical changes occurring here. So rust formula is nothing, that is hydrated ferric oxide, means you can say Fe2O3.XH2. This is hydrated ferric oxide, and this process is named as rusting, and this is a chemical change. How can we say that this is a chemical change? Because in chemical change new substances are formed, okay, and new compounds are formed. Or you can say chemical change as like what? If new substances or new compounds are formed, so definitely composition of old substances will change. Composition of old substances will change. So you know very well, first of all, as we had introduced what is a chemical reaction, now I want to recall the another point. How can we represent this chemical reaction on paper? If we are saying rusting is happening, if we are saying suppose Mg is reacting with O2, that means magnesium is reacting with oxygen and it is forming magnesium oxide. So I am saying orally, but how can I write this? So this is called the representation, and the representation of a chemical reaction or writing of a chemical reaction on paper, we can write in two ways. First is chemical equation, another is symbolic form or symbolic equation. What is this chemical equation? In chemical, or you can say chemical equation can be written in word form, word equation, or in symbolic equation. So word equation is like magnesium. I am writing the names of elements and compounds, or simply you can say reactants, because you know very well chemical reaction, in chemical reaction reactants gives products. Reactants are those species or those substances which are undergoing a chemical change, and they will react with each other and they will form products, right? They will form products, they will interact and transform into new substances, and those new substances are known as products. Those new substances are known as products, and this is the general representation of any chemical reaction. Reactants are giving products, and there is a separation arrow. You can see here the head of the arrow representing the formation of products and the tail of the arrow representing the reactant side, right? Okay, so you can say just by looking at this general representation, you can say simply that Mg plus O2 are reactants and MgO is product, right? So if I want to represent the chemical equation, right, with the help of these two ways, and while writing on paper, so we can write a word equation, and the second one is symbolic equation. What is this word equation? So you can write magnesium plus oxygen is giving magnesium oxide, is giving magnesium oxide. The another symbolic equation, in symbolic equation we can represent the word equation by writing the, we can represent the chemical equation, or we can convert the word equation into symbolic equation just by writing the symbols of elements and the compounds in the reactant side and product side. So magnesium symbol is Mg, oxygen symbol is O2, and they are reacting and they are forming magnesium oxide, which is MgO. So this is the symbolic equation, and this is the word equation. Word equation is not very useful because it does not show the stoichiometric coefficients. It does not show how many reactants are reacting with each other and how many products are forming. It does not show so many things. So it is not very much informative, but symbolic equation is highly informative as compared to word equation. If after balancing, if you will write this equation, so you will find like Mg solid is reacting with oxygen gas and it is forming 2 MgO solid, and you have to write 2 here. So now you can see, now it is very much clear. Just by looking at this equation, you can see like 2 Mg are reacting with 1 O2 and they are forming 2 MgO. It means the stoichiometric coefficients of reactants and products are very much clear to you. And also it is clear like what is the physical state of the reactants and products. The physical state of Mg is solid, for oxygen it is gas, for MgO it is again solid. So symbolic equation is informative equation. It gives information regarding the number of moles of reactants, kitna amount, how much amount of reactants are reacting and how much amounts of products are produced. That is the point here. Okay, so word equation and symbolic equation, these are the two equation. After that, if you had written the chemical equation on paper, so it should be balanced. So there are two types of chemical equation. One is a balanced chemical equation, one is a balanced, and another is unbalanced. Unbalanced chemical equation is also named as skeletal chemical equation, right? Skeletal chemical equation, that means that is not balanced. The total number of atoms of each and every element in the reactant side and product side are not equal. But in it balanced, the total number of atoms of each and every elements in the reactant side and product side are equal. So I am writing here only equal, and I am writing here unequal. I am writing here unequal. So this is the representation. So balanced chemical equation is following the law of conservation of mass. In the previous grade, in the 9th grade, you have understood what is a law of conservation of mass, because you know very well, according to law of conservation of mass, the total mass of the reactants must be equal to the total mass of the products. It means you can, in a balanced chemical equation, it means you can say the total mass of the reactant side must be equal to the total mass of the product. Means number of atoms of each and every element in the reactant side is equal to the number of atoms of each and every element in the product side. But in a balanced chemical equation, it is not following the law of conservation of mass. Not follow law of conservation of mass. Follow law of conservation of mass. Follow law of conservation of mass. Then after this balanced and unbalanced, there are certain steps that how can you convert this unbalanced chemical equation to balanced chemical equation. How can you balance any skeletal equation? So chemical reactions are happening. So based on that, we had some types of chemical reactions. Types like you can say combination reaction. You can say like a decomposition reaction. Combination reactions are generally exothermic. It means we had two more terms like exothermic reaction and endothermic reaction. The another type is decomposition reaction. In decomposition, reactions are generally endothermic. I will give you an overview, then we will start the NCERT exercise. Okay. Then displacement reaction, or you can say single displacement reaction. Then double displacement reaction. Double displacement reaction. Another is like redox reaction. In redox, we had two terms: oxidation, oxidizing agent, and reduction, reducing agent. Okay. And after the types of chemical reaction, we will go with the corrosion and rancidity, two important terms. And that is all about this. We will go with the corrosion and rancidity, these two important terms regarding the food and metals. And then we will go with the NCERT exercise. So this is the overview of the entire chapter of chemical chemical reaction and equations. So let's begin with the NCERT exercise. First question, very interesting or very important question. So you know very well what is oxidation. So I am giving you an overview of combination. What is combination? When two or more reactants are combining to give a single product, that is known as combination reaction. They are generally exothermic. Exo means exit, thermic means like heat. So exit of heat, exit of energy is taking place, exothermic reaction. When a single reactant is breaking down into multiple product, that is decomposition reaction. So we are providing energy, like lead nitrate will break down, right? So you can see they are endothermic reaction. That means they required energy. So absorption of energy is taking place here. Absorption of energy. Displacement reaction, according to activity series, there is a reactivity series in which metals are arranged, in which elements are arranged according to their reactivity. According to their reactivity, top to bottom reactivity decreases, and the most you can say most reactive is potassium, and after that you will go with platinum, right? So this is what reactivity series. So in displacement reaction, a more reactive element will displace the less reactive element from its salt solution or compounds. They can be acid base reactions, okay, like that. So A plus BC gives AC plus B. That is, so A is more reactive here than B. In double displacement reactions, what is happening here? Exchange of ions will take place. Exchange of ions means like AB plus CD. So A will combine with D, and C will combine with B. That means A will combine with D, so you will get AD, because cation then anion, and cation then anion, so you will get CB. This is cation, C is cation, and B is anion. So AD plus CB. In redox reaction, when oxidation reduction reactions are occurring simultaneously in a particular reaction, that are known as redox reaction. Redox reactions, there are two terms like oxidation. Oxidation is nothing, that is the addition of oxygen and removal of hydrogen, and also you can say loss of electron is known as oxidation. Reduction, addition of hydrogen, removal of oxygen, or also you can say gain of electron is also known as reduction. And oxidation, there are two more terms, oxidizing agent and reducing agent. So oxidizing agents are those agents which reduce Oxidizing agents are those agents which oxidize others and reduce itself, and reducing agents are those agents which reduce others and oxidize itself, right? So whatever is the name, right, oxidizing agent, so it will reduce itself. If reducing agents, it will oxidize itself and reduce others. Similarly, corrosion and rancidity. Corrosion is like when any metal comes in the contact of atmospheric gases like hydrogen, like oxygen, moisture, and other acidic gases, so it will get decay, right? It will get decay. So the decay of metal due to the attack of atmosphere gases over the surface of metal, that is known as corrosion. Like in case of iron, it is known as rusting, or in case of copper and silver, it is known as tarnishing. Apart from this rancidity, rancidity, like the spoilage of food, is known as rancidity. You can see here the chips packets, right? After some time, if the packet is open, and after some time, it will get what? It will absorb the moisture, as well as the smell and taste of the food, or smell and taste of the chips will get changed. So if the smell and taste of the food will get changed, it means the food becomes rancid food, okay? The food becomes rancid due to the oxidation. That's why in chips packets nitrogen gas is filled, okay? Okay, so now let's begin with the exercise questions. This is the first question of today's class. So which of the statements about the reaction below are incorrect? The question is asking a very simple thing. The question is saying that which of the statements out of A, B, C, and D, there are four statements, and for this particular reaction, which one is incorrect? The reaction is saying that 2 lead oxide, that means 2 moles, you can say 2 moles of lead oxide, PbO, plus 1 mole of carbon is reacting, and you will get 2 mole of Pb, that is lead, plus 1 mole of CO2 gas. Okay, so you can write, if you are not getting a clear idea, you can write that CO2 is a product. You can write here also. So you can see here the lead oxide so is converting itself into lead. That means removal of oxygen will take place. Removal of oxygen or addition of hydrogen means reduction. So it is getting reduced. It is getting reduced. Reduced by what? Reduced by carbon, because carbon is converting itself into CO2. It means carbon is in carbon, addition of electron is taking place. It means carbon is getting oxidized. It means carbon is getting oxidized. If carbon is getting oxidized, itself oxidize and reduce others, that is known as reducing agents. So carbon is acting as a reducing agent. It means the species, the atom, the element which is undergo oxidation will act as reducing agent, and the compound, the element which is acting as which is undergoing reduction will act as oxidizing agent, will act as oxidizing agent. This is the main point, will act as oxidizing agent. So lead oxide is getting what? Reduced, and carbon is getting oxidized. Don't go with the product side whenever the oxidation and reduction word are there. Only see the reactants. So lead is getting reduced. Lead is a product, so it will never the answer. Carbon dioxide, which is CO2, is getting oxidized. Carbon dioxide is the product, so it will not the answer. Carbon is getting oxidized. Yes, carbon is undergoing oxidation. Correct. Lead oxide is getting reduced. Yes, lead oxide is undergoing reduction. Definitely option C and D is the correct statement. So you can see option, the question is asking incorrect. So C and D are correct. So what will be the correct answer? A and B are incorrect. So this is the correct answer, not 2, 3 and 4. Always, always you have to be very careful while reading the question. Always read the question with patience, because in questions the statement is saying that incorrect. Tell me the incorrect statements. And sometimes we can make this type of simple mistake. Okay, we can mark it correct. So what is the correct answer? Option 1. So you can see answer 1, A and B is the correct answer, and I told you the explanation how can we say that this first option is the correct answer. Let's move to the next question, which is like a reaction is given to you, Fe2O3 ferric oxide reacting with aluminium. It is giving aluminium oxide plus 2Fe. Okay, the above reaction is an example of, you can see Fe2O3, okay, and it is going to Fe. Always see the reactants, then go to the product side, find the same element Fe2O3, find Fe here in the product side. You can see Fe2O3 is converting itself into only Fe. It means removal of oxygen. Removal of oxygen, yeah, loss of oxygen, you can say loss of oxygen. If loss of oxygen is there, so you can say definitely reduction. So Fe2O3 is undergoing reduction, or Fe2O3 is reduced here. On the other hand, if you will go with aluminium, so aluminium is adding of oxygen is taking place, and it is converting itself into aluminium oxide. So aluminium is nothing, that is what? Aluminium is undergoing oxidation. Aluminium is undergoing oxidation, because addition of oxygen is taking place while converting aluminium to Al2O3, aluminium oxide. So this reaction is an example of what? This reaction is an example of combination reaction. In combination reaction, multiple reactants combine to give a single product, but we are getting two products here, so it is not a combination reaction. Double displacement reaction. In double displacement reaction, we have actually two salt solution or two compounds, or here in the reactant side only one compound and another is a single metal, or single element, you can say. In double displacement reaction, exchange of ions will take place. Okay, so this is not a double displacement reaction. Decomposition reaction, a single reactant must be there, and it will decompose into, or it will break down into multiple products. So multiple products, that means two products are there, but the reactants are also two. Reactant must be only one, so it is not the answer. The correct answer is option D, because aluminium is more reactive than Fe. According to the reactivity series, aluminium is more reactive than Fe, and if aluminium is more reactive, so you can say a more reactive element can displace a less reactive element from its compound or its salt solution. So aluminium is displacing, aluminium is substituting Fe from its Fe2O3 compound, then it will form Al2O3 plus 2Fe. So this is the correct answer. Ferric oxide plus aluminium gives aluminium oxide plus 2Fe. So the correct answer is displacement reaction. So let's see the solution. You can see the answer D. The given reaction is an example of a displacement reaction. I hope you are very much aware how can we solve this question, how can we show the approach, how can we take the use of elimination method. Okay, let's move to the next. What happens when dilute HCl, means dilute hydrochloric acid, is added to iron filings? Iron filings is what? Fe, right? So you can write solid. So Fe solid is reacting with dilute HCl, means aqueous. It means whenever metal plus acid, you know a reaction, when metal plus acid are reacting with each other, they will form what? Metal reacting with acid, they will form salt and hydrogen gas is released here. And there is a test for hydrogen gas. What is the test for hydrogen gas? Definitely when metal plus acid reacting, they will form salt and hydrogen gas. And hydrogen gas, whenever we bring any matchstick or any burning candle near the hydrogen gas, it will burn with a pop sound. Okay, it will burn with a pop sound. So the question is saying that what happens when dilute Cl is added to iron filling? So Fe plus HCl, or you can write dilute HCl, gives FeCl2 plus hydrogen gas. You can balance this equation just by putting 2 here. So Fe plus 2HCl gives the ferrous chloride plus H2 gas plus H2 gas. So this is the answer for this particular question. This is the answer for this particular question. Even you can say hydrogen gas and iron chloride are produced. So hydrogen gas and iron chloride. Chlorine gas, no reaction takes place, wrong. Iron salt and water are produced, wrong. So in this case, option A is the correct answer. Fe plus 2HCl gives FeCl2 plus H2. Okay. Also, you can write like this. You can see hydrogen gas and iron chloride are produced. The reaction is as follows. Fe solid plus 2HCl aqueous gives FeCl2 aqueous plus H2. This representation, this upward arrow is representing this is a gas. So for gaseous products, you can write this upward arrow, as well as for solid products, if the products are in PPT form, so you can write this downward arrow. That means precipitate are formed here. Okay, aqueous means those this is present in water, in which the solvent is water. The solutions in which the solvent is water are known as aqueous solutions. Okay, so the correct answer of this particular question, as I told you already, option A. Metal plus acid gives salt and hydrogen gas, and the test for hydrogen gas is pop sound. What is the test? Pop sound is the test for hydrogen gas. What is the test for CO2 gas? For CO2, we can pass the CO2 gas through lime water. Lime water gets milky. If you will pass the excess of CO2 through lime water is nothing, that is the aqueous solution of calcium hydroxide. If you will pass the excess CO2 through this lime water, what will happen? This milkiness will again convert into colorless, or you can say transparent. That means it will again becomes transparent, or you can say excess of CO2 is passed here. Okay, so let's move to the next question, which is a very interesting question. What is a balanced chemical equation? As I told you already, balanced chemical equation is that equation which represent actually how many reactants and how much amount of reactants are reacting to produce how much amount of products, right? It means the chemical equation which follow the law of conservation of mass. Why should chemical equation be balanced? Because chemical equation follow the law of conservation of mass, and according to law of conservation of mass, total mass of the reactants must be equal to the total mass of the products. Okay, like you have seen the seesaw, right? So it's like a seesaw. If the weight here and here are not same, so it look like this and this. If there is a But if the both weights on the seesaw is same, so it will look like this. So it should be balanced. It should be balanced. So what should be the correct answer? The answer of this question is the chemical equation needs to be balanced so that it follows the law of conservation of mass, as I told you already. A balanced chemical equation occurs when the number of the different atoms of elements in the reactant side must be equal to the atoms of different elements of the product in the product side. Let's move to the next question. Next question is saying that translate the following statements. Only you have to translate. The question is not saying that balance. And then if we will read the question after this translate, then it is showing that balance them. So first of all, we have to translate the following statements into chemical equation and then balance them. Chemical equation also named as what? Symbolic form, and these are the statement form. Okay, word form. So hydrogen gas combines with nitrogen to form ammonia. So first of all, let's write this hydrogen gas combining. So H2 gas is combining with N2 gas to form ammonia. Okay, so it is forming NH3. Next one is hydrogen sulfide gas. H2S gas is burned in air. Burning is happening in the presence of oxygen. So H2S plus O2 gives water. It means H2O plus sulfur dioxide. It means SO2. Now, first of all, while balancing, I want to tell you the steps of balancing quickly. If you want to balance any unbalanced or skeletal chemical equation, first of all, write the skeletal equation, then make a tabular form. Write the number of elements of each and every number of atoms of each and every element in the reactant side and product side. So I am writing elements here. Here I am writing reactants. Here I am writing products. So how many atoms are there? Only I am balancing this a particular reaction first. Then you can balance others. just by following these similar steps. Elements are only hydrogen and nitrogen. How many hydrogens are there? 2. How many nitrogens are there? 2. How many hydrogens are there? 3. In the product side, how many nitrogens are there? 1. If you will make it 2, while balancing the equation, always remember you need not to change any type of subscript. You can change only the front side. Okay, you cannot change. You can change only the stoichiometric coefficient. You cannot change the subscript. Okay, so you can see here nitrogen and hydrogen both are not balanced. How can we balance this particular equation? Suppose you want to balance the nitrogen. How can we balance nitrogen? You can put a 2 here. If we will multiply, okay, this is a hit and trial method. You can make a hit and then check it is balanced or not. If it is not balanced, you can make another hit, then check. So you can see the number of atoms of nitrogen in reactant side is 2 and the number of atoms of nitrogens in product side are 2. If we will multiply this ammonia with 2, if we put a coefficient here in front of ammonia, then it will become 2NH3, and now the number of nitrogen is 2 here in the product side, and number of nitrogen atoms in the product side reactant side are also 2. So you can see the number of atoms of nitrogen in the reactant side and product side are equal. If the number of atoms of nitrogen in the reactant side and product side are equal, and for balancing nitrogen atoms, we had done with we had put a coefficient 2 here in front of ammonia. So the number of hydrogen atoms are also changed in the side of in product side. So now you can make another table. I am just doing in the same, or I can make another box, or I can write in the product side after balancing. You can see the number of hydrogen atoms in the product side now is 6 and the number of nitrogen atom is 2. So nitrogen atoms in the reactant side and product side are same, but you can see hydrogen are 6 in the product side and in the reactant side only 2. So you can make a 3 here. You can put a coefficient 3 in front of H2 in the reactant side. Then you can see the balanced chemical equation becomes 3H2 and it is a gas plus N2, which is also a gas, gives 2NH3, which is also a gas. Now the question is saying translate then balance. So we had translated and balanced also, and the complete balanced chemical equation is this, because now the total number of atoms of each and every element in the reactant side and product side are equal, and also we had written the physical state. After writing the physical state, the balanced equation is complete. So you can see 3H2, 6 hydrogens, on total 6 hydrogens in the reactant and product side, and that means both sides are equal, 6 and 6. In the reactant side, 2 nitrogen, in the product side, 2 nitrogen are also there. I hope this is clear to you. Similarly, you can balance this hydrogen sulfide gas burns in air to give water and sulfur dioxide. If you will follow all the steps, like first of all write the skeleton chemical equation, then follow the step, make a tabular form and write the elements of each and every, write the number of atoms of each and every element in the reactant side and product side, make a tabular form like this. So you can see if you will balance this, you can see 2 hydrogen, 2 oxygen, and total 2 plus 1 3 oxygens are there. If you will multiply with 3, so 3 to the 6 oxygens, and if you will multiply with 3 here, so what will happen? 3 plus 2 5. No, we can't multiply with 3 here. So how can we balance this equation? It is very simple. If we will put 2 here and 2 here, so it will become 2 to the 4. Now 2 sulfur, let's put 2 here. 2 to the 4, 2 to the 4. So 2 to the 4 oxygen plus 2 oxygen, 6. Total 6 oxygens are there. And 2 sulfur, 2 sulfur. 2 to the 4 hydrogen, 2 to the 4 hydrogens. Now you can see the number of atoms of each and every element, which is hydrogen, oxygen and sulfur, in the reactant side and product side are equal. Let's move to the next, C and D. Question is saying that barium chloride, which is BaCl2, reacts with aluminum sulfate, which is Al2SO4 whole thrice. You understood already. How can we write the formulas, right? You know cations, you know anions, and how to write chemical formula just by using cation and anion, by using their valencies, you know, and you had understood in the previous grade 9. It is giving aluminum chloride means AlCl3 plus a precipitate of barium sulfate BaSO4. According to your grade, if precipitate word is there, so it will be a precipitation reactions, and most probably it will be a double displacement reaction. So this is an example of double displacement. Next is potassium metal, which is K, reacts with water H2O it will give potassium hydroxide, which is KOH, and also the release of hydrogen gas is taking place here. So K plus H2 gives KOH plus H2. So for your homework, you can balance these two equations. I want to show you the answer of these four equations, but you can balance these. Okay, you can balance, then you can check your answer. So the correct answer of A is 3H2 plus N2 gives 2NH3. Now the atoms of each and every element in this equation is balanced. I told you already how you can balance the unbalanced chemical equation. Next is 2H2S plus 3O2 gives 2H2O plus 2SO2, right? I written here 2H2O, 2H2S plus 3O2. You can see it 4 hydrogen, 4 hydrogen, 2 sulfur, 2 sulfur, 6 oxygen and 6 oxygens. 2 to the 4 plus 2. Next one is 3 BaCl2 plus Al2SO4 whole thrice plus 2 AlCl3 plus 3 BaSO4. You can see 3 barium, 3 barium. You can see total 6 chlorine. You can see 3 to the 6 chlorine. You can see SO4 thrice. You can see 1 SO4 into 3, 3 SO4. And you can see a 2 aluminum, 2 aluminum. So everything is balanced here in the reactant side and product side. That means the number of atoms of each and every element in the reactant side and product side are balanced. Next is 2K plus 2H2 gives 2KOH plus H2. So potassium, you can see, plus water gives potassium hydroxide plus hydrogen gas, and this hydrogen gas can be tested by pop sound. How can we test this? How can we detect this? By pop sound. Just by what? Just bringing the burning matchstick, or just bringing the burning candle near this hydrogen gas. So 2K on the left side and right side, 2 potassium. In the left side, 2 the 4 hydrogen, right side only 2 hydrogens are there and 2 hydrogens are there, so 4 hydrogens are there. Similarly, left side 2 oxygen and right side B, there are 2 oxygens. Okay, so this is the answer of this particular question. Let's move to the next question. Balance the following chemical equation. In the previous question, we had give what we got the statements. Then first of all, we had converted the statements into chemical equations and then balanced. Okay, then we did the balancing. Now you can see we got this chemical equation, unbalanced chemical equation, you can say, and we have to convert this unbalanced chemical equation into balanced chemical equation. How can we balance? You know all these steps, you can balance these. I want to tell you the answer. Like you can see, 1 hydrogen, this is nitric acid reacting with calcium hydroxide, it will form calcium nitrate. Calcium hydroxide is like a base, this is an acid, so it will form salt and water. You can see 1 calcium, 1 calcium. You can see 2 oxygen plus 3, 5 oxygens are there. You can see only 3 to the 6 plus 1, 7 oxygens are there. You can see 2 hydrogen, only 1 hydrogen, 2 and plus 1, 3 hydrogens are there. Like that you can balance this equation. Similarly, NaOH plus H2SO4 gives Na2SO4 plus H2O. If you will put 2 here, so can you see this is balanced or not? 2 NaOH, so you can put 2 also here. Now this equation is balanced. 2 NaOH, 2 Na, 2 Na, 2 oxygen plus 4 oxygen, 6 oxygen. So 2 plus 4, 6 oxygen, and 2 hydrogen plus 2 hydrogen, 4 hydrogens, and 2 to the 4 hydrogens. Then sulfur, only one, and oxygens are counted here. Similarly, if you will balance this, calcium hydroxide gives calcium plus HNO3 gives calcium nitrate, CaNO3 whole twice plus H2O. If you want to balance this, you can also balance this very simply. You can see total 2 nitrogens are there. So first of all, you have to put 2 here. So now you can see 2 hydrogen plus 2 hydrogen, 4 hydrogens. So you here only 2 hydrogens, so 2 to the 4. Now you can see 3 to the 6 plus 2, 8 oxygen, and you can see 2 or 3 to the 6, 8 oxygens are there. 2 nitrogen, 2 hydrogens balanced, nitrogen balanced, oxygen balanced. Calcium 1, calcium 1, this is also balanced. NaCl plus AgNO3 gives AgCl plus NaNO3, this is already balanced. This unbalanced chemical equation is already balanced. BaCl2 plus H2SO4 gives BaSO4 plus HCl. So you can see SO4, SO4, Ba, H2, HCl. So you can put 2 here. Now you can see H2, 2H, Cl2, 2Cl. So this is also balanced. You can see the answer of this particular question will be 2HNO3 plus CaOH whole twice gives calcium nitrate plus 2H2. This is a balanced chemical equation. 2 NaOH plus H2SO4 gives Na2SO4 plus 2H2. This is again balanced chemical equation. 2 NaOH. 2 NaOH means sodium hydroxide. You can see here 2 NaOH. And also you can see the next one is NaCl plus AgNO3, NaCl plus AgNO3 gives AgCl plus NaNO3. This is already balanced. And BaCl2 plus H2SO4 gives BaSO4 plus 2HCl. Whatever we had written, you can see the answer of this particular question. And this is not the what I can say. This is not the short trick. You have to solve each and every part with all these steps and then match your answer. Okay, so this is the answer of this particular question. Let's move to the next question. Write balanced chemical equation for the following reactions. Reaction is, you have to write balanced. So first of all, this is the word form. Let's change it into informative form, which is a symbolic form. Calcium hydroxide, which is nothing, that is CaOH whole twice. Carbon dioxide, which is CO2. Carbon dioxide is acidic in nature. Calcium hydroxide is basic. It will form salt, which is calcium carbonate plus water. Zinc, Zn, plus silver nitrate. Zinc is reacting with AgNO3. Zinc is more reactive than Ag, so it will form zinc nitrate, ZnNO3, or plus silver. Plus silver. Next is aluminium plus copper chloride. Copper chloride, it means you can write CuCl2. Okay, CuCl or CuCl2, both you can write. That's depend on you. If you are writing CuCl, so it is cuprous chloride. If you are writing CuCl2, it is cupric chloride. So metals can show two types of variable valencies. You can say metal can show variable valencies, like Cu can show Cu plus and Cu2 plus. For lower valency, we have to use us, and for higher valency, we have to use ik. For example, Fe can show Fe2 plus and Fe3 plus. So Fe2 plus is named as ferrous, and Fe3 plus is ferric. Okay. It is forming aluminium chloride, which is AlCl3, plus copper, which is Cu. Next is barium chloride, BaCl2, plus potassium sulfate, K2SO4, gives barium sulfate, BaSO4, plus potassium chloride, that is potassium chloride, KCl. Now you can balance this unbalanced chemical equation. You can follow the law of conservation of mass and all the steps, whatever I told you, while balancing any unbalanced chemical equation. So you can see the answer for this particular question is calcium hydroxide plus CO2 gives CaCO3 plus H2. This equation is already balanced because you can see 1 calcium, 2 oxygen, and 2 plus 2, 4 oxygen. So 3 plus 1, 4 oxygen. You can see 2 hydrogens are there. You can see 1 carbon is there. So this equation is already balanced, so need not to follow any steps. Only you can make tabular form and you can write the answer. Next is Zn. Don't write the answer if the question is asking, if the number of questions, if the question having marks 3 or more than 3. Just don't write the answer in one word or one line, or don't write the direct balanced chemical equation. Always, if the question is having marks more than 2, or question contain marks more than 2, so definitely you can go with the steps, okay, while balancing any unbalanced chemical equation. Like Zn plus 2 AgNO3 gives ZnNO3 whole twice plus 2 Ag. So 2 silver, 1 Zn, 1 Zn, NO3 2, NO3 2. This is already balanced chemical. Not already. We had we have put 2 in front of AgNO3 and 2 in front of Ag. In the product side Ag, and in the reactant side in front of AgNO3, right? Okay. Then 2Al plus 3CuCl2 gives 2AlCl3 plus 3Cu. Aluminium. So this is an example of what? This is like acid base reaction. This is Zn plus 2 AgNO3. Displacement, single displacement you can say. This is also a single displacement reaction because aluminium is more reactive than copper. Here zinc is more reactive than silver, and here aluminium is more reactive than copper. Okay, silver, gold, platinum, these are copper. These are like what? These are like least reactive metals. These are like least reactive metal. This is a double displacement reaction. So in aluminium, in the C1 you can see 2Al, 3Cu, 3Cu, 3 to just 6 chlorine, 2 3 just 6 chlorine. In the last one, this is a double displacement reaction. Barium chloride is reacting with K2SO4. Potassium sulfate is giving BaSO4 barium sulfate plus 2 KCl. So for balancing this particular unbalanced chemical equation, we had done with a coefficient 2 here. We had put a coefficient 2 in front of KCl, and now the equation is completely balanced chemical equation. I hope you are very much aware how to write the steps of while balancing the unbalanced chemical equation, and how can we prove that this equation is unbalanced chemical equation, this equation is a skeletal equation, and how can we convert the unbalanced chemical equation into balanced chemical equation. Okay, So this is all about this particular class. After this class we will go to the next class, and then we will discuss the next questions apart from this NCRT exercise question. Not apart from these particular questions, we will discussing the next NCRT exercise questions. I hope you got each and every concept how can we solve the questions of NCRT exercise. Okay, so thank you so much everyone, we will meet soon in the next class.